Embratel, vamos criar juntos o próximo nível.
Nosso painel, o dia de hoje, é sobre o futuro da TV 3.0. E para o próximo painel, nós vamos então ouvir José Marcelo Amaral, que é o presidente do Fórum SBTVD e diretor de Operações e Engenharia da Record TV. Marcelo, novamente, seja muito bem-vindo, espero que a conexão esteja restabelecida. E acompanhando o Marcelo na moderação do painel, está conosco também Luiz Fausto de Souza Brito. Luiz Fausto é coordenador do módulo técnico do Fórum SBTVD. E para este painel, temos a presença de 5 convidados internacionais. Meninos, é com vocês.
Olá, amigos da SET e a todos que participam desse painel, boa tarde. Eu gostaria de agradecer o convite e parabenizá-los pela iniciativa diante desse momento de tanta adversidade. Agradecer também aos nossos ilustres palestrantes por terem aceitado o nosso convite, a senhora Madeleine Noland, presidente do ATSC, o senhor Masayuki Sugawara, presidente do DiBEG, os senhores Aziz, que é gerente de produto da Schwarz, e Thomas Stock, que é diretor técnico da Qualcomm, o senhor Shanshe Wang, que é presidente do AVS Alliance, e, finalmente, o Luiz Fausto, que é coordenador do módulo técnico do Fórum. Eu penso, senhores, que não é demasiado a gente reforçar, sempre que possível, a importância da televisão aberta do Brasil. Ela é a principal plataforma de distribuição audiovisual. Ela cobre quase todos os lares brasileiros e é utilizada em mais de 70% deles. Enquanto outros meios estão com dificuldades para se manterem, a TV aberta continua garantindo à maioria da população o acesso gratuito, universal, democrático à informação e ao entretenimento, mesmo diante de tanta competição. Além disso, é importante fator de coesão social, identidade nacional e cultural. Eu aqui represento o Fórum Brasileiro de Televisão Digital Terrestre e quero compartilhar com vocês que o nosso principal papel é assessorar o governo em questões políticas e técnicas relacionadas à aprovação de inovações, especificações, desenvolvimento e implantação do Sistema Brasileiro de Televisão Digital Terrestre. Diante de um cenário onde o modo de consumir o conteúdo televisivo está avançando para além das fronteiras que estávamos acostumados, o Conselho Deliberativo do Fórum definiu um plano de trabalho com o objetivo de propor evoluções ao nosso sistema de televisão digital, de tal forma a torná-lo ainda mais atrativo e mais próximo da realidade atual. haja vista que o mundo é muito mais conectado, é mais diverso, é mais interativo e muito desafiador. Acredito que vocês já tenham conhecimento dos incrementos que nós fizemos no nosso sistema quando criamos um novo padrão de interatividade, o que a gente chamou de DTV Play, e da possibilidade de melhorar ainda mais a experiência para o usuário com os novos padrões de áudio imersivo, vídeo HDR, que surgiram com o que denominamos a TV 2.5. Vocês podem ver aí na apresentação que a TV demorou muito tempo para sair da época analógica para digital, e talvez sejamos o último da cadeia a fazer essa transformação. Agora a gente está partindo para uma etapa mais arrojada, que é preparar o caminho para um novo padrão de TV. Esse que nós estamos chamando de TV 3.0. Por conta disso, realizamos meses atrás uma chamada pública a fim de conhecer e avaliar novas técnicas e padrões de TV ao redor do mundo, que estivessem em linha com aquilo que vislumbramos para o futuro. Para desenvolver um pouco mais desse tema, eu queria passar a palavra para o Fausto, que é coordenador do módulo técnico, que ele vai abordar um pouco mais de detalhe. Fausto, é com você. Obrigado.
Obrigado, José Marcelo. Obrigado a Sete pela oportunidade de tratarmos desse tema aqui. Obrigado a todos os convidados desse painel. Como o José Marcelo mencionou, o Fórum SBTVD estabeleceu um cronograma de trabalho no qual a gente publicou um chamamento internacional de propostas de tecnologias para a próxima geração de TV digital terrestre no Brasil, o projeto TV 3.0, que foi publicado em julho deste ano. Também publicamos em outubro os procedimentos de avaliação e teste dessas tecnologias e recebemos, até o dia 30 de novembro, as respostas do que nós chamamos de fase 1 desse Call for Proposals, desse chamamento. Essa fase 1 era basicamente uma identificação dos proponentes e propostas e uma autodeclaração de quais requisitos eram preenchidos por cada proposta. Então, nós estamos exatamente agora na fase de análise dessas respostas para poder prosseguir para a fase 2. Na fase 2, a gente espera receber a especificação completa dessas tecnologias até o final de janeiro, equipamentos para teste no início de abril, até o início de abril, para realizar os testes aí entre abril e setembro do próximo ano, com a expectativa de analisar os resultados e ter uma decisão sobre as tecnologias a serem adotadas no final do próximo ano, e iniciar em 2022 o processo de elaboração das normas técnicas e poder publicar as normas técnicas da próxima geração de TV digital terrestre no Brasil. Essa chamada de propostas, ela era para 6 diferentes componentes da arquitetura: a camada física, a camada de transporte, codificação de vídeo, de áudio, captions e codificação de aplicações. E nós recebemos, até o dia 30 de novembro, nós recebemos 36 propostas dentro desses 6 componentes. Em relação à camada física, nós recebemos 5 propostas, sendo que 2 endereçavam a mesma tecnologia, né? E nós temos hoje aqui representantes dessas 4 tecnologias que foram oferecidas: o ATSC 3.0, DTMBA, o ISDBT avançado e o 5G Broadcast, que vão poder apresentar em alguns detalhes as propostas deles. Também recebemos diferentes propostas para as tecnologias de camada de transporte, diferentes propostas para as tecnologias de codificação de vídeo, de codificação de áudio, de captions e de codificação de aplicações. Então, enfim, foram um grande número de respostas que ainda vão ser estudadas, analisadas e testadas ao longo do próximo ano. E esse painel de hoje, então, vai permitir uma primeira visão com alguns dos principais proponentes que estão aqui representados, né, para a gente ter uma primeira visão do que eles estão propondo de tecnologias para a TV 3.0. Eu também gostaria só de mencionar, antes de passar adiante, que além dessas 36 respostas que nós recebemos dentro do prazo, nós recebemos uma resposta fora do prazo do DVB, que, enfim, o Fórum SBTVD ainda vai discutir como será tratada essa resposta. Bom, então, com isso, eu agradeço a atenção de vocês, coloco o Fórum SBTVD à disposição para maiores informações. No site do Fórum, podem obter a documentação completa e mais detalhes sobre esse projeto TV 3.0. E para iniciar, então, a apresentação aqui das tecnologias que estão sendo propostas, eu gostaria de chamar o senhor Mohamed Aziz Taga e o senhor Thomas Stockhammer para apresentar a proposta do 5G Broadcast. O Mohamed Aziz Taga é gerente de produto e líder de desenvolvimento de negócios da Rohde Schwarz, e o Thomas Stockhammer é diretor de normas técnicas da Qualcomm. Então, Aziz, Thomas, please, you have the floor. Thank you.
Thanks a lot for the invitation. We are really happy as two companies, Rohde and Schwarz and Qualcomm, to join a venture for this proposal, for phase 1 proposal for TV 3.0 project. And the topic would be around 5G broadcast, or ENTV as it is listed in the standard. So basically, within the agenda today, we would talk about the future vision that we have in mind and that we are trying to adopt. Then the new business verticals that we would really try to reach via this new technology as a global one. The technical solution, definitely as a very, very high technical level explanation how this could be embedded and enabled. Then I will leave the floor to my colleague Thomas to explain more about the broadcasters' challenges, as well as the role of 5G in protection, as well as distribution. And on top of that, closing the presentation via giving an overview, a bit of technical spices, I would say, in relation to ENTV in the status of ENTV in the 3GPP release 16. So I would start with the vision. Basically, what we see as an industry leader, as a technology leader, we see that there is a lack of convergence between broadcast network operators, BNO, and mobile network operators, due to the fact that both of these industries are, of course, totally separate, and they have different kind of business, and also they have different kind of challenges. But if we focus in details, we can find that there is really a potential of a win-to-win situation between these two different industries, distant industries. If we look to broadcasters, actually their main challenge is to reach over the customer anywhere, anytime, and at any kind of devices. And they basically believe right now that the change of the customer behavior could dramatically change their business orientation. On top of that, their daily business, which is linear TV, is losing popularity against streaming services. And this is a fact that we all know. And from the other side, of course, smartphone and tablets are gaining more and more importance, and mobile applications are also becoming more and more needed. But due to the fact that BNOs don't have access to portable devices, they are still struggling how to create and enhance their current business and create a new one. For mobile operators, of course, like any other industry, they have also their challenges, and these challenges are mainly in relation to the high or exponential increase of data consumption in their network, which is at the end of the day limited once it comes to one-to-one communication. And when we talk about data in general, it includes, of course, mobile video consumption, where there are many of these kind of mobile video consumption that could be used in a broadcast and multicast manner, and where we can see the first key topic of a cooperation between both entities. And the challenge here for mobile network operators is, of course, delivering the right quality of service and the right experience to their end users, at least the experience that they are expecting. What we see actually within Rohde and Schwarz is that we are looking into providing an efficient solution for an efficient media delivery anywhere, anytime, and to everybody. That's the main concept that summarizes everything. How? This is actually basically could be done via the utilization of a global approach, a universal approach for using broadcast and multicast together with unicast for bidirectional communication, for reporting, for uplink in general. And this is anyhow addressed by EMBB, Enhanced Mobile Broadband, as a main corner of 5G. Technically speaking, this could be feasible via the deployment of an overlay network for one-to-many, or a SDL concept for a mixed mode implementation within the existing cellular network, where there is a potential agreement between broadcasters and mobile network operators. And these two different solutions, I will talk about it later briefly, solution 1 and solution 2. From frequency perspective, of course, the part of the UHF or part of the UHF band is a strong candidate for this implementation, but it's not a must because there are many SDL frequency bands that are described and defined by ITU that are still not used in many countries worldwide that could be used for this application. From business perspective, it is definitely necessary to make this happen and this fruitful, to implement a kind of business model that we are, for example, calling it as a multicast as a service that enables a cooperation between a concrete cooperation between broadcasting industry and mobile telco operation industries. This would allow broadcasters making their infrastructure and their business much more dynamic, and making mobile network operators making less and less investments. From application perspective, we have a bunch of applications. Some of them they are known, some of them maybe they're not so famous. Live casting is in relation to live of big and popular events, including linear content, but also anything that could be updated over the air is in relation to over-the-air multicast as a segment here. Vehicle casting is attracting and addressing media and entertainment inside the vehicle as one of the sub-applications, but not only limited to that. Of course, there are over-the-air updates, over-the-air real-time traffic, and so on. Venue casting is one of the emerging use cases that is in relation to localized broadcast and multicast concept, where we are looking into enhancing the venue atmosphere and the fun atmosphere and the fun experience with a home live experience at the same time. Public safety is a must in any country, and we can see the need of public safety specifically in the pandemic situation. Esports is one of the angles that are also attracting the usage of broadcast and multicast, and as well as on top of these, there are other applications like live commerce, remote and rural e-learning, where internet connection is not feasible and the implementation of mobile network is too difficult and too costly. And there are other applications like many applications in the field of e-agriculture and also the video on demand distribution. From solution perspective, actually, it is called 5G broadcast. Technically speaking, it is called FEMBMS, further enhanced MBMS. It is known in 3GPP. And we are addressing two different, or let me say it the other way, it's three different solutions that are feasible here. The first solution is a very simplified connection between content providers, live, on demand, OTT, whatever type of content, to a broadcast multicast core, and from the broadcast multicast core to the radio access network, which is based on high power or medium power solution, which is referred here as an overlay network on top of the existing cellular network. And the solution 2 is actually based on cellular implementation, where broadcasters can provide their asset, which is a broadcasting and multicasting experience, into the cellular network, where they can share some of the sites, for example, and they can deploy a software or cloud-based solution that will enable a localized broadcast and multicast. And instead of implementing this solution in each site separately, this solution can be implemented every 5 or 7 sites to reduce highly the cost and to make the distribution of the content as much as efficient as possible. I tried to summarize my part at least as much as I could. And right now I leave the floor again to my colleague, Thomas Stockhammer. Thomas, the floor is yours.
Yeah, thank you, Aziz. We only have 2 or 3 minutes left, but I want to give quickly just an overview from the perspective we took at standardization, how Qualcomm approaches it. So we're opening up basically the 3GP world, the cellular world, to new verticals. And basically, by doing so, you get broadcasters who are able to reach new devices and distribute new media. And with the replacement cycle and the innovation you get on mobile, you basically get these things relatively easy and for free. So it's IP-based, internet-based, it's cellular and Wi-Fi, and basically now we integrated, as was said by Aziz, high power, high tower. That addresses traditional needs of broadcasters, but it also gives you a path into the new media and all of the new devices. And in many countries, and I believe Brazil is not different, mobile is, for example, quite often the first device for consumers. So Aziz, if you go to the next slide. So 3GP 5G is not a vertical service, but it's built as a platform that allows you to run many services. And for broadcasters, for example, you can run your production of a 5G, and you can run a TV service, and then you rely on globally available technologies that are built for multiple purposes, where you have codecs, like built in MPEG. You have service layers. For example, we have a portability of DVB, internet-centric service layer that you can run on 5G. So it's not that 5G provides you the full stack, the vertical service, but it provides you a platform you can build on top innovation and convergence with global standards. So Aziz, if you go to the next slide. That just addresses and makes it concrete. There's a couple of examples where very concretely work has been done in 3GPP. I leave this for offline consumption, but if you move to the next slide, just in the interest of time. So what was happening that over the timeline over 6-7 years, 3GP basically integrated a high power, high tower functionality for 3GP and for 5G. And that was supported broadly by a lot of companies, which you see below. They're all in the broadcast domain. So there's a lot of interest from what we call verticals in 3GP in creating requirements. And these requirements were put into technology enablers. And release 16, which was just completed a couple of months ago, is ready to go from the specifications. And that's where our proposal builds on. And I go to the last few slides. If you move it forward. So as said, so we have a DVB-I as an example for a service layer. DVB is, for example, working on this. But however, DVB is just an example. For example, we have technologies aligning fully with what ATSC did in 3.0, IP-based, using Dash and CMAF, using root. But there's a service layer that is IP-centric. So this just gives you a very clear idea that you can run multiple service layers on this innovative platform. And the final slide, Aziz, before we close this. So once you're in this 5G wave, you basically open up a lot of opportunities because 5G is this massive cycle of innovation. And the next things are already in the pipeline. We have release 17 coming up where we have edge processing, AI, we have 8K, there is XR, extended reality VR. So basically, once you move into this 5G context, you get many things for free from a technology perspective. Thank you, obrigado. I hand back to the organizers.
Well, thank you very much. Thank you, Thomas. Thank you, Aziz, for your very interesting, clear presentation. Now I'd like to call Mr. Masayuki Sugawara. He's from DiBEG to present their proposal for the TV 3.0. Thank you.
Thank you, Luis. Can you see my slide?
Yes, thank you.
Okay, good afternoon, everyone. So my name is Masayuki Sugawara of NEC and the chairman of DiBEG, Digital Broadcasting Experts Group. Firstly, I'd like to congratulate that SBTVD Forum has compiled the requirements for TV 3.0 and issued the call for proposal. And it is my great pleasure to respond to it. Now I would like to briefly explain our response. So let me start with the background of the response. So digital terrestrial television has started in 2003 in Japan. And the main service is HDTV, and MPEG-2 video is used for video coding, and MPEG-2 TS is used for transport layer, and the physical layer is called ISDVT. As you know, current Brazilian DTTV uses ISDVT and H.264 video codec. So in Japan, the standardization process for next generation digital terrestrial is now ongoing with the target year of 2023. Therefore, we could not respond based on established standards for next generation DTTV. However, this does not mean that the technology related to digital broadcasting has not progressed in the last 20 years. IVB system called Hybrid Cast has started the year of 2013, and 4K and 8K satellite broadcasting has started in 2018. Which uses UHD-TV for application, HEVC for source coding, and MMT for transport layer, and ISDB-S3 for physical layer. These technologies and standards, except for the physical layer, would be highly related to the next generation terrestrial. So regarding terrestrial broadcasting, national projects have been conducted since 2013 in Japan, and they are the final stage toward the standardization by the year of 2023 at this moment. So Alive DiBEG believes that the accumulation of such experience and knowledge will contribute to the study of TB3.0 in Brazil, and decided to respond to CFP, although standardization for next generation terrestrial broadcasting is still in progress in Japan. So let me explain the standardization bodies in Japan. The broadcasting technical standards are developed based on the report of MIC, the government council. So Alive Standardization Committee is tasked to develop domestic standards. As I mentioned, next generation DTTV standardization work in progress by these organizations. So Alive also has a promotion strategy committee. So DiBEG belongs to with the aim of the international promotion of ISDBT. So this response was submitted by DiBEG, intending to contribute as much as possible to the call for proposal in the current situation. So now I'd like to explain the DiBEG's response. So regarding physical layer, it adopts MIMO and expanded occupied bandwidths and new segmentation structure and newly designed LDPC codes and non-uniform constellations. And this achieves spectral efficiency nearby the Shannon limit. Also achieves the flexible selection of the bit date depending on the required service. So experimental results obtained in national products are also provided as a supplemental information. For transport layer, the MMT is assumed, which is based on Alive STD B60 standards, which was developed for advanced satellite broadcasting. For video coding, the VVC is assumed, and image format up to 8K is assumed. For audio coding, MPEG-H is assumed, and channel-based and object-based audio are assumed. For caption, the response is based on Alive TTML specified in Alive standard B62. The application layer, the response is based on HTML5, and the architecture design is based on Jinga HTML5 and Jinga CC web services. And some parts additionally refer to Japanese standards, including hybrid cast, that is the IPv system of Japan, and advanced broadcasting service, and also web standard of W3C. So this is a summary of DiBEG's response to SBTVD forums TV3.org call for proposal. Thank you.
Thank you. Thank you very much, Mrs. Sugawara, for your concise presentation, and very complete and concise. Thank you very much for that. And now I'd like to ask Ms. Madeleine Noland from ATSC to give us a brief overview of their proposal. Ms. Noland, the floor is yours.
Thank you, Luis, and thank you to everyone for this opportunity to present at SETE Experience 2020. So, let's see, make my slides go. Here we go. This proposal was put forth by ATSC, as it was mentioned in the introduction item. The ETRI from Korea was also proposing a very similar or the same physical layer as ATSC, so I kind of speak for ATSC and for ETRI. ATSC is a standards development organization, international, approximately 150 member organizations from across the globe. ATSC 3.0 has been under development and was completed and deployed in Korea in 2017 and is being deployed here in the United States in 2020 and into 2021. One of the best things about ATSC 3.0 is that it was developed by the best and brightest people across the globe from many countries and many stakeholders within the broadcasting ecosystem. As a result, we have ATSC 3.0, which is for broadcasting in the internet era. The physical layer is flexible and configurable. It is currently the world's most efficient one-to-many DTT system available. Transport is IP-based using MMTP as well as root dash. Video is based on H.265. Audio includes Dolby AC4 and MPEG-H audio. Application-based is HTML5, CSS, and JavaScript with additional WebSocket APIs for television. Accessibility is greatly enhanced. We use IMSC1 for captions, and picture-in-picture is possible for sign language, etc. The advanced emergency messaging system is very robust with new rich media capabilities, receiver wake-up, geo-targeting, etc. The system is also capable of data casting as we look to use the broadcast spectrum for a wide range of new verticals, such as delivering data to the Internet of Things, cars, agriculture, digital signage, smart cities, distance learning, telehealth, etc. And the other exciting thing about it is that it is convergence ready. It's designed to easily interoperate with other IP data delivery networks, such as Wi-Fi, wireline networks, 5G, 4G, etc. So we studied the call for proposals in great depth across the entire ATSC organization, and we compiled our responses in much more detail, I can assure you. Poor Luis probably has a lot of work to do to look through all the responses, not just ATSCs. But in terms of the physical layer, ATSC 3.0 is fully compliant. On the transport layer, there was one piece, which is the use of IPv6 and OTA that might need to be added, but otherwise entirely compliant. On the video coding layer, there were questions about 8K, 5K and such like, but those things are all extensible. And beyond that, of the 59 requirements, 55 are fully functional within ATSC 3.0 today. And in the other areas, we're also pretty much 100% in audio coding, 29 of 29, captions, 19 of 19, and applications, we sort of called ourselves 43 out of 39, 39 out of 43. But I think the main thing is that with a shim above the W3C based technology, we can integrate seamlessly with Jinga APIs. So in terms of the physical layer, one of the most important things about ATSC 3.0 is its closeness to the Shannon limit. With non-uniform constellations, new LDCP codes, and other innovations, ATSC 3.0 is the most efficient system on the planet today, coming as close to the Shannon limit as any has come before. It's also entirely flexible. You can choose the trade-off between bitrate and robustness according to the need of a given market, and you can do more than one of these things at the same time. There's no commercially mature system that comes closer to the Shannon limit, and sub-zero dB operation is supported and proven in commercial deployments. The technology is very mature. It is commercially deployed in South Korea, currently reaching roughly 70% of the population in all of the major cities in South Korea. And in the United States, deployment is going apace. We are probably going to be reaching roughly 50% of the population by next summer, and probably 75% of the population by this time next year. So I'd also like to spend a little bit of time on the advanced emergency information. We have components for wake up. The advanced emergency alert signaling table provides all the information the receiver needs to know. It enables geo-targeting, targeting to public and private audiences, and prioritization, all kinds of things. Interactivity is seamlessly integrated with the emergency alert table. And we also incorporate watermarks to enable the emergency information to traverse a wide variety of networks, including through an HDMI cable or any other type. ATSC 3.0 also has security features. The security for the studio to transmitter link. We have security for the signaling tables and the applications so that receivers can validate the source of the emission. And there's also content encryption available based on Common Encryption, CENC, to allow for a wide variety of types of services. And it's also uniquely suited to LTE 5G convergence. The specification and the 5G specification anticipates non-5G networks in the ecosystem with the ATSSS document. ATSC 3.0 is currently a DTT standard that's readily convergent via the bootstrap because it's an all-IP system. It's time-aligned with LTE and 5G, and it has a similar OFDM numerology. There may be new work in ATSC to fully realize the scenario, but one of the other good things about ATSC 3.0 is that it can be expanded, and extended according to the needs of different countries. So growing on that particular point for a moment, it allows ATSC 3.0 is extensible, and it allows broadcasting to grow and evolve without abandoning existing viewers and businesses using initial 3.0 deployments. So if ATSC 3.0 was deployed in a particular region and a new feature was to come along, that region could implement the new feature without orphaning their existing viewers and businesses. And there are many technical design decisions within the standard that make this possible. Everything from using XML-based signaling tables to using JSON to enabling evolutionary physical layer frames via the bootstrap. In fact, in Korea, in particular ETRI, new features of ATSC 3.0 are being developed and tested now, including delivering 8K and VR/AR using the MIMO channel bonding and hybrid OTA/OTT capabilities of the service today. And ATSC welcomes collaboration with SBTVD to adapt the ATSC 3.0 platform to meet the unique needs of the Brazilian people. And I would extend that to say that ATSC also welcomes collaboration with the other proponents of the system so that SBTVD can develop the premier system for the Brazil marketplace. I'd also like to note that ATSC 3.0 is in a pretty good sweet spot for the Brazil adoption today. It's both mature as well as extensible. So it's in its 4th year of commercial deployment, as I mentioned, and reaching US households roughly this time, 2021, 75%. And so we have a rich ecosystem of consumer devices and a rich ecosystem of broadcast solutions, including a prototype cell phone. But it's also extensible, and there's lots of room for new players. The platform is extensible, and the ecosystem is kind of greenfield right now. So there's a lot of opportunity for input from both SBTVD and from Brazilian manufacturers, as well as Brazilian inventors, as well as the other proponents that are working together on this system. So just to reiterate, ATSC 3.0 is very closely compatible with all of the requirements of the SBTVD CFP. The few that are not yet supported can be added, and we look forward to working with others to do that. And the system is mature and ready to go, in fact, deployed today. So we think that it is very well suited to the very aggressive timeline that Luis Fausto laid out, looking to complete all the work by 2022 and be ready to deploy. So that's a very aggressive timeline, and we think that ATSC 3.0 is in a great position to fulfill that desire. Obrigada. Back to you, Luis.
Thank you very much, Madeleine. And finally, I'd like to call Professor Wang from the AVS Alliance to introduce us to the Chinese proposal that DT now provide to the TV 3.3.0 call for proposals. Mr. Wang, the floor is yours.
Okay, can you see it?
Yes.
Okay, hello everyone. It is a great honor for me to have the chance to introduce AVS. Okay, today I will merely introduce AVS 3. Which is the latest national video coding standard in China. Okay, this is outline. Firstly, I will provide you some background. AVS is a working group on video coding standards in China, which is founded in 2002. One of the missions for AVS was to make a royalty-friendly standards. AVS adopts patent pool-based policy and attract many companies to join the group. This helped AVS to grow up with more than 100 members worldwide. And AVS standards help become international standards. It has been used in many other countries. Okay. And now AVS has currently set up 7 subgroups, that is request and test system, video, audio, digital media rights management, implementation, and IPR. AVS member can choose join any one or every one of the subgroups. And AVS is open for all members who agree with AVS policy. Let us come to the AVS standards. AVS working group has released a series of coding standards, also known as 3-generation standards. Namely AVS 1, AVS 2, and AVS 3. They all aimed at broadcasting applications and internet streaming. Let's mainly say something about AVS 3. The development process of AVS 3 can be divided into 2 phases. In the first phase, AVS working group officially released call for proposal in December 2017. The phase 1 of ABS array aimed to achieve a good trade-off between the complexity and the coding gain, defined as main profile. Okay, the phase 1 of ABS array has been technically ready in January 2019. Okay, moreover, ABS array decoder chip has been released in IPC 2019 by Huawei in September 2019. Okay, and ABS array phase 2, defined as high profile, is still going on. In the second phase, ABS array will continue to improve the coding efficiency and plan to be released in 2021. Okay, next I will introduce some features of ABS array. This slide shows some key coding tools of ABS array phase 1. You can see ABS array still follows the block-based hybrid coding framework. It is the same with ABS2 and HBC. Okay, but block partition, Qt, BT, plus EQT partition is proposed to improve the coding flexibility. Okay, for intro prediction, IPF and TSCPM are adopted, which improves the luma and chroma prediction accuracy, respectively. Okay, for intercoding, many new coding tools are adopted, including HMVP, AMVR, FORUM, and so on. Okay, for transfer models, okay, PPT is adopted. Okay, and now ABS array phase 2 is still in the development. Okay, currently it can achieve nearly 9% coding gain compared with ABS array phase 1. Okay, some new coding tools are adopted in phase 2. Okay. Okay, let's go on. The following tables shows the technology comparison between VVC, AV1, and ABS3. And you can see that they have a lot of different coding tools to achieve the performance improvement. Maybe they have their own advantages. Okay. Okay. Let's look at the text results. Okay. These two tables shows the performance compared with HBC and AV1. Okay, on the left, it can be seen that ABS3 can achieve about 28% coding gain on average compared with HBC. And on the right, you can see that about 9% coding gain can be achieved compared to AV1. Yeah, it is the test results. Okay, if you are very interested in ABS3, you can get the source code from the following links. Okay, and this open source has taken a lot of optimizations. Okay, let's go. Okay, besides video coding standards, EVS also developed audio coding standards named as AVSA. Yeah. Okay. AVSA provides multi-channel based, object-based 3D audio and scene-based codec solution. Until now, more than 50 films and TV programs have been produced in AVSA formats. Okay, and more than 300 theaters have adopted AVSA cinema decoder. Okay. Okay. Let's say something about smart media transport. Okay. Okay. SMT. Yeah. MST is a next generation media transport standard developed at AVS 2.6, and it is on Chinese national standard application stage. Okay, SMT is an IP-based media transport layer protocol that supports emerging convergence service over networks. Okay, the system inputs could be any type of media data, including timed and non-timed contents, as well as configuration information. The system output is the synchronized multimedia service with high quality, strong flexibility, and great reliability. The broadcast and broadband channels are both included in the delivery networks. This is smart media transport. If you want to get further information, you can get them from the following links. And if you want to connect with us, you can send the email to the to the following address. Okay. Let's come to the summary. Okay, EVS has a footprint of millions of users and devices for upgrading, both in China and internationally. And for EVS3, EVS3 will be used for 8K OTT, and as efficiencies will also benefit for HD. As well known, EVS2 has already been published via AEEE, and EVS3 will be published soon. Okay. One point is very important. That is, EVS3 has clear position on IPR and listening. Okay. That's all. Thank you.
Thank you very much, Mr. Wang, and indeed, thank you very much for all the speakers. Unfortunately, our time has come to the end, and we won't have enough time for Q&A, for questions and answers. So we had received a lot of questions, but as our time has finished, we'll answer these questions later by email to the participants. So I'd just like to thank you all very much, and hope to see you soon, and hope to meet you all in person next year in SCD conference. See you.
Thank you.
Obrigada.
Thank you.
Bye-bye.
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 Obrigado.
Thank you. Bye-bye.
Obrigada, Luiz Fausto, e também a todos os seus convidados pela possibilidade de conhecermos em primeira mão algumas das tecnologias que no futuro poderão estar à disposição de todos nós telespectadores brasileiros. Agora eu gostaria de dar um recado para você que está aqui acompanhando a nossa live. Nós tivemos muitas perguntas, mas como estamos com um tempo avançado, posteriormente as perguntas serão respondidas por e-mail para aqueles que a indicaram. Vamos responder tudo, ninguém vai ficar sem resposta. E aproveito para lembrar que no site do Set Experience Academy temos a trilha Como Ir da TV 2.0 à TV 3.0, produzida por empresas internacionais parceiras da SET e que também nas trilhas Distribuição e Consumo e Acadêmica temos vários vídeos sobre TV 3.0, então fica esse recado, essa dica. Aproveite, estes conteúdos ainda continuam abertos. A gente volta daqui a pouquinho, não saia daí.